You know the feeling, right? You ask your AI assistant to do something that seems totally simple, find a hotel, book a car, and it just messes up. It gets confused, it gives you the wrong info, it's frustrating. The AI seems so powerful, but the second it needs to connect to the outside world, to an external tool, something just seems to break. Well, today we're going to dig into why that happens and uncover this hidden weakness that trips up even the smartest models out there.
So let's start with a really simple everyday request. You ask your AI, find me a car rental with a cleanliness rating above 8. I mean, that sounds super straightforward for a fancy large language model, doesn't it? All it has to do is look up some data and spit back an answer. Easy peasy.
But this is what the AI gets back from the car rental company's system. It's not some neat little list. It's this massive, complicated-looking data file called a JSON. And all that is, really, is how computers talk to each other. But you can see the problem, right? The answer you want, that cleanliness rating, is buried somewhere deep inside all that code. So here's the million-dollar question. How on earth does it sift through all of that noise to find the one tiny piece of information it needs? And maybe more importantly, why do even the most cutting-edge AIs on the planet get this wrong so often? We are about to find out.
It really all comes down to what you could call the AI's reading problem. Now, I'm not talking about reading English like you and me. I'm talking about reading the structured, often messy language of the digital tools and APIs that basically run the internet.
The official term for this is tool response processing. It's this one critical step where the AI has to make sense of all that data a tool sends back. And what new research is showing is that this is a huge and honestly a surprisingly overlooked weak spot for pretty much every AI agent out there. To really get to the bottom of this, a team of researchers decided to put these AI models to the test. They basically set up a digital obstacle course, a test lab, to see how good today's top AIs really are at this one specific, tricky task.
And let me tell you, this was a serious stress test. They didn't just make stuff up. They gathered real, messy data from actual APIs. We're talking car rentals, hotels, even SEC filings. Then they wrote almost 1,300 questions and put 15 of the best models through the ringer, from GPT-4o to Llama 3, and they tried out a bunch of different ways of asking to see what actually worked best.
They even split their questions into 3 levels of difficulty. First up, you have extractive questions. These are just simple lookups, like find this one piece of info. Then it gets a little harder with filtering, where it has to find all the cars that meet a certain rule. And finally, the hardest of all, aggregation, where the AI actually has to do a calculation, like finding the highest rating in the whole list.
So, after all that testing, what did they find out? Well, the results were pretty fascinating, and they boiled down to 4 simple rules for anyone who's trying to build a smarter, more reliable AI assistant.
Okay, rule number 1 is going to sound a little weird at first. It turns out it's actually better to ask the AI to write a little piece of Python code to find the answer, instead of just asking it for the answer directly.
And just look at the difference here. For the really complex tasks, asking for a direct answer only got it right about 58% of the time. But asking it to generate code to find the answer, it was accurate an incredible 98% of the time. That's a 40 percentage point jump in accuracy. That's huge.
Rule number 2 is all about giving the AI some context. Think of it this way. If you're sending someone into a new city, you give them a map so they don't get lost, right? Well, for an AI reading a data file, that map is called a JSON schema. It just outlines the structure of the file. And the payoff is totally clear. Just by including that little map in the prompt, performance shot up by as much as 12%. That's a really simple thing to add, but it makes a massive difference, especially when you're asking the AI to write code.
All right, rule number 3 kind of confirms something a lot of us have suspected about these models. They get overwhelmed. It's like the needle in a haystack problem. The bigger the haystack of data you give them, the more likely they are to miss the needle or make a mistake.
And you can see it plain as day in this chart from the study. As the amount of data the AI has to read gets bigger, the accuracy for almost every single model goes down, down, down. For some models, the performance just absolutely plummets. We're talking a drop of over 90%. Ouch.
So what do you do if the response from a tool is just too big? I mean, it won't even fit in the AI's context window. Well, the research has a clear answer for that, and it's rule number 4. Giving it a condensed, summarized version of the data is way, way better than giving it nothing at all.
Let's just look at the numbers. Yeah, of course, having the full response is best.
But check it out. Providing a condensed version is still so much better than just giving it the map, the schema, and nothing else. You might take a small hit on accuracy, but it's a much smarter strategy than just throwing your hands up.
Okay, so we know what works and what doesn't, but let's dig a little deeper into the why. Why do even these super powerful models fail at what seems like a simple reading task? The researchers did a real deep dive into all the mistakes to find the root cause.
And they found 4 main culprits. Sometimes the AI just flat out misreads the structure, like it'll grab the right piece of information but from the wrong car. Other times it gets tripped up by what they call semantic ambiguity, like confusing a data field called room_name with one just called name. It also just struggles to follow formatting instructions, and sometimes the code it writes just plain breaks.
And as the researchers themselves put it, the biggest villains here are just the complexity and messiness of real-world data. So it's not really that the AI is dumb, it's that the information it's being asked to read is often confusing, poorly labeled, and just plain messy.
So with all this new knowledge, how can someone who's actually trying to build an AI application use this stuff? Well, the study gives us a fantastic, super practical field guide.
Check this out. This decision tree basically brings it all together. It's like a cheat sheet that guides you to the best strategy for whatever you're building. It asks the simple questions. Can the data fit? Are your questions easy or hard? Is the data clean? By following these steps, you land on the best approach, whether that's asking for a direct answer or using that more powerful code generation method.
And really, the big takeaway here is that there is no magic bullet. There's no one-size-fits-all solution. Building a truly reliable AI agent isn't about just grabbing the biggest, most powerful model. It's about being thoughtful and really smart about how that model reads and interacts with data from the outside world.
Which kind of leaves us with one last big question to think about. We spend so much time and energy talking about making AI models bigger, more creative, more human-like. But maybe, just maybe, the real final frontier, the last hurdle before we can truly trust these things with important real-world tasks, is something a lot less glamorous. Just teaching them how to read the instructions properly.